space is actually much stranger than you think. One of the most breathtaking events on Earth, total solar eclipses, only happen because of a cosmic coincidence. The sun, in reality, is about 400 times larger than the moon, but it's also about 400 times further away. Those two improbable ratios match so perfectly that the sun and the moon appear to look almost exactly the same size in our sky. This alignment is incredibly rare in the universe. Most planets either have moons that look tiny compared to their star, or moons that appear huge and easily cover it. But thankfully, Earth's moon is at just the right distance to create a perfect fit, allowing total solar eclipses where the sun's outer atmosphere, the corona, suddenly becomes visible. This incredible event for humanity won't last forever. The moon moves away from Earth at about 3.8 centimeters per year. So in about 600 million years' time, total solar eclipses will stop happening entirely. But they show just how precise cosmic forces can be, and up in orbit, gravity is still at work in ways most people don't even realize. Way up above our heads right now is the International Space Station and its crew. Floating because, as many people may think, there's no gravity up there. But that's not actually true. At the space station's altitude, gravity is still about 90% as strong as it is on the surface. So the question begs, why do astronauts appear weightless? Well, that's because they're in a constant state of free fall. The truth is, the space station is falling towards the Earth, but at the same time, it's also moving sideways at about 28,000 kilometers per hour. Going sideways at that speed keeps it continuously missing the planet. And that creates microgravity, where everything on that space station falls together at the same rate, making it look like gravity has vanished. But gravity isn't the only thing shaping life beyond Earth. Water, one of the universe's essential ingredients, is far more common than you might think. When we think of water, we usually imagine oceans, lakes, and rivers here on Earth. But water isn't rare in the universe. In fact, it's surprisingly common. Astronomers have in fact discovered huge amounts of water in space, from icy comets and frozen moons to massive clouds of water vapor drifting between the stars. One of the largest known reservoirs is a gigantic cloud surrounding a distant black hole, containing enough water to fill Earth's oceans more than 100 trillion times. We also find water on several moons in our own solar system. Europa and Enceladus, for example, have global oceans hidden beneath their icy crusts, with more water than all of Earth combined. Even Mars shows signs that liquid water once flowed across its surface. All of this is exciting because water is one of the key ingredients for life as we know it. And the more water we find out there, the more possible it becomes that life may exist somewhere beyond Earth. It sounds impossible, but Saturn, the second largest planet in our solar system, is actually less dense than water. If you could find some sort of gigantic cosmic bathtub big enough to hold it, Saturn would literally float. That's because Saturn is made of hydrogen and helium, two extremely light gases. And even though Saturn is over 760 times bigger than Earth, all that gas spreads out over such a huge volume that its average density ends up being lower than water's. Of course, this doesn't mean Saturn is soft or fluffy. Its gravity is still strong, and the deeper you go, the more pressure you'd experience. But overall, when scientists calculate its density, Saturn comes out at about 0.69 grams per cubic centimeter, compared to water's 1 gram per cubic centimeter. So while the idea of a floating planet sounds like science fiction, Saturn proves that in a weird world of planetary physics, it's completely possible. Another planet that somewhat defies the world of planetary physics is Neptune, who's so far from the sun that a single year there lasts an incredibly long time, roughly about 165 Earth years. That means since humans first discovered Neptune in 1846, it has completed only one full orbit around the sun. Because it's nearly 4.5 billion kilometers away, the sun's gravitational pull is much weaker out there, so Neptune moves slowly through space. Its seasons last over 40 years each, and sunlight takes more than 4 hours to reach it. This enormous orbit is one of the reasons Neptune stayed hidden from ancient astronomers for so long. It wasn't actually found by looking through a telescope. It was discovered through math. when scientists noticed something strange about Uranus's motion and predicted another planet must be tugging on it. So even though we've been studying Neptune for nearly 2 centuries, it still only finished one trip around the sun. Venus is probably one of, if not the strangest planets in our solar system, and one of its weirdest quirks is all to do with time. A single day on Venus lasts about 243 Earth days, but Venus completes a full orbit around the Sun in only 225 Earth days. That means a day on Venus is actually longer than a year. This slow rotation makes the Sun move across the Venetian sky incredibly slow. If you were standing on its surface, you could watch the sun crawl across the horizon for months at a time. Scientists are still trying to understand why Venus spins so slowly. Some theories suggest ancient collisions, or perhaps interactions with its thick, toxic atmosphere gradually slowed its rotation. Either way, Venus completely challenges our ideas of what a day and a year should be. And another one of its strangest features is that it actually spins backwards compared to most other planets. On Earth, the sun rises in the east and sets in the west because our planet rotates counterclockwise. Whereas on Venus, the sun would rise in the west and set in the east, literally the complete opposite. Scientists think Venus didn't always rotate this way. As we mentioned before, something dramatic must have happened in its past. Venus could have been struck by a massive object billions of years ago, hard enough to flip its rotation. And whatever the cause, Venus rotates extremely slowly. It's a reminder of the chaos that has gone on and will go on forever in our solar system. Moving away from planets, gamma ray bursts are without a doubt the most powerful explosions we know of in the universe. In just 10 seconds, a single gamma ray burst can unleash more energy than our sun will produce over its entire 10 billion year lifetime. Frankly, that's not just impressive, it's almost impossible to comprehend. These bursts usually come from catastrophic cosmic events like the collapse of a massive star into a black hole or the collision of 2 neutron stars. When that happens, enormous jets of energy blast out at nearly the speed of light. If one of those jets is pointed towards Earth, even from billions of light years away, we can detect it. Thankfully, they're incredibly rare in our galaxy, but their raw power is a swift reminder of just how violent the universe can be. That's not to say our sun is weak, however, and our sun's light speed shows just that. One of the coolest things we've learned about our sun is that the light we see isn't happening in real time. It actually takes about 8 minutes and 20 seconds for light to travel from the sun to the Earth. That means that every sunrise you see is technically a view of the sun from more than 8 minutes in the past. Light is incredibly fast, about 300,000 kilometers per second, but the distance between the Earth and the sun is even more incredible, roughly 150 million kilometers. Even at light speed, that journey still only takes just a few minutes. This also means that if something were to suddenly happen to the sun, like it magically vanished, we wouldn't know immediately. For just over 8 minutes, Earth would keep orbiting normally, and the sky would look exactly the same. So the sunlight warming your face right now, it started its journey when you were doing something completely different 8 minutes earlier. We're used to hearing loud, epic explosions in sci-fi films, but the true reality of our cosmic universe is you wouldn't hear a thing. Sound needs a medium, and space doesn't offer one. It also needs air, or at least some kind of material to travel through. In the vacuum of space, there's no molecules to carry vibrations. So that means if 2 spacecraft collided, or if something exploded nearby, for instance, you wouldn't hear a thing. Even massive cosmic events like supernovas happen in complete silence. You may ask why astronauts can speak through their radio. Well, that's because their helmets have air inside. But outside of that, nothing. Absolute quietness. It's strange to imagine floating in a place where movement, destruction, and even entire galaxies exist without sound. So it's true, in space, no one can hear you scream. It might sound strange, but black holes, which are famous for trapping light inside, can actually give off light in a few different ways. How that works is that the light doesn't actually come from inside the black hole. Nothing can even escape beyond the event horizon. Instead, The light comes from the extreme environment around the black hole. As matter falls towards a black hole, it forms a fast, spinning accretion disk. Friction and gravity end up heating that material to millions of degrees, causing it to shine incredibly brightly. Some black holes can also launch huge jets of charged particles that glow as they blast through space at nearly the speed of light. There's also Hawking radiation, which is a theoretical process where black holes slowly lose energy over time and emit tiny amounts of light, although this hasn't quite been observed directly. So even though the black hole itself stays perfectly dark, the space around it can be one of the brightest and most energetic places in the universe. Now, everyone's heard of black holes and what they do. But what's less known is that black holes have a theoretical opposite, something called a white hole. While a black hole pulls everything in, a white hole would do the exact reverse. Nothing could enter it, and anything inside would be forced outwards. White holes come from the same mathematical equations that describe black holes, which makes them really interesting on paper, but so far we've had zero observational evidence that they actually exist. If they did, they could potentially, like cosmic fountains, eject matter and energy into space. Some scientists have even speculated that a white hole could look a lot like the Big Bang, an explosion of matter appearing from nowhere. For now, white holes do remain purely theoretical, but they show how strange and imaginative physics can get when we push the limits of what's possible in our universe. Back to planet Earth now and our closest neighbor, the Moon. The distance between the two might look small in photos, but in reality, it's actually huge. On average, the Moon is about 384,000 kilometers away from us. To put that in some sort of perspective, the gap is so large that you could line up every single planet in the solar system, Mercury through to Neptune, side by side, and they would all fit comfortably in the space left between the Earth and the Moon. That blows a lot of people's minds, including mine, because we tend to imagine the Moon as just being up there, almost within reach. But the reality is that the Earth-Moon system is gigantic. The Moon is so far away that during the Apollo missions, it took astronauts about 3 full days to travel up there. So the next time you look up at the Moon, remember, there's enough room between you and that glowing disk to fit Jupiter, Saturn, Mars, Venus, and every other planet with a little space left over. If you ever stood on the surface of Mars and watched the sun go down, you wouldn't see the warm reds and oranges we get on Earth. Instead, you'd see something completely different, a blue sunset. And the reason for this lies in the dusty Martian atmosphere. Mars is filled with fine dust particles that are excellent at scattering red light in all directions. During most of the day, this makes the sky appear a reddish or butterscotch color. But at sunset, when sunlight has to pass through even more dust, something unusual happens. The red light gets scattered away, while the blue light travels straighter and slips through towards the viewer. The result, a soft, eerie blue glow that surrounds the setting sun, a sight captured by multiple Mars rovers, including Spirit, Opportunity, and Curiosity. So while Earth gives us fiery sunsets, Mars delivers something cooler and more alien, a calm, dusty world painted in shades of blue as the sun dips below the horizon. When we think of asteroids, we usually picture small, lonely chunks of rock drifting through space. But some asteroids are far more complex, and some can even have rings and moons just like planets. One of the most surprising discoveries came in 2014, when astronomers found that the asteroid Chariklo, a small object only about 250 kilometers wide, has 2 distinct rings made of ice and dust. Later, another asteroid-like object, Haumea, was also found to have a ring. But rings aren't the only surprises. Many asteroids have their own moons too. In fact, about 15% of near-Earth asteroids are actually binary systems, 2 objects orbiting each other. Some even have multiple moons, like the asteroid Sylvia, which has 2 small companions named Romulus and Remus. These discoveries prove once again that our solar system is full of the most unexpected wonders.